Howdy, howdy, this is Mr. Potter. Now that we've got a lot of the fundamentals down for C++, we're actually going to start trying to code up some of these data structures that we're talking about. That's really going to be the focus of most of this course. So the first data structure that I want to talk about is the array list data structure. Now you may remember the array list from Java, where we would have a list object that had interface things. So we could add to a list, we could remove from a list, we could set and get to deal with elements in the list. And the main idea was that we had an array that was private, and we had methods to access the data in the list. The array list was a much easier way of getting in and out of the data because the Arraylist class structure actually dealt with the process of adding stuff to the array or removing stuff from the array. So what I want to do is I actually want to implement this in C++. So I'm going to be creating an Arraylist class just like we created a fraction class, which means that we're going to have an Arraylist.h that's going to contain the header file, all of our prototypes for our class. And then we're also going to have an Arraylist.cpp, which will contain all the code for it. The main thing that I actually want to talk about here in this Arraylist.h was the concept of templating. In ArrayList, remember that we had our angle brackets. So if I wanted to declare an ArrayList, we would do something like ArrayList of type integer foo gets new ArrayList of type integer. And so this is how we constructed an array list, and the only thing that we could put inside that array list were integer objects. I want to kind of set this up that same way, where if I have some way to deal with this integer template, this idea that I can determine this at the time of construction, that I can later deal with that in the code, which means that the array that we're going to have is going to be an array of integers, and we're going to have integers as our parameters. If we're writing the parameters, how do we ensure that the integers, or whatever class was typed, are that way? We don't have to guess all the possible classes. Certainly with what we wrote about the fraction class, there's no way for the designers of C++ to think that we were going to come up with the fraction class on our own. And so what we're going to do is deal with the concept of templating. So I'm going to start off this code with the way that we did before. I'm going to get a define preprocessor directive, and we're going to define ArrayList.h. And then of course later on in our code we're going to have our include ArrayList.cpp. And in our Arraylist.cpp, we're going to use our if and def Arraylist_h. Then we're going to include Arraylist.h, and then endef. Excuse me. So now that I've got this stuff done, this is just the class stuff. What I need to do now is I need to set up the template. So I'm going to set up some template with some class which I'm going to call T. It really doesn't matter the name of this class. This T I'm going to be using as a variable for the name of my class that I'm going to be using throughout. So instead of having to guess, am I dealing with an integer or a char or a string or a fraction, I'm just saying I'm dealing with an object of type T. And so this type T is what we're actually going to use throughout our class definition of ArrayList. And so we're going to make sure we terminate that with a semicolon. We talked about when we were doing our ArrayList class that we have two sections. We have a private section and a public section. And our private section is going to contain some things. For example, I know that I want an array of type T. But we've talked in our arrays unit, in our pointers unit, that we can think of an array as a pointer. So I really want a T pointer called data. And then in my constructor, I can determine the size of this array. I also want two integer variables. One that's going to keep track of my array length. And keep in mind, this is the length of the actual array. And I also want something called list size, which is going to be the number of elements the list contains. And then I want two helper methods up here. I actually want a helper method called resize, which is going to resize the array if necessary. And we'll talk about how to do that in just a little bit. And I also want a Boolean function called need to resize, which will determine if we need to resize. Keep in mind that if I have 20 spaces in my array, then I can hold up to 20 objects. And it's only when I need to insert object 21 into that array that I need to resize it. In other words, only when I'm going to be doing an add, and only when I'm going to, when the number of elements in our list equals the array length. So these are going to be our private information. And in our public, I want to implement the stuff that we had in our array list. So we're going to need to have some type of constructor. So an Arraylist constructor. We're going to need some accessors. So we would have something like bool contains, which would look to see if it contains an item of type T. And of course, this would return either true or false. We'd probably need an int index of that item and an int last index of that item. And by the way, I'm getting these functions from the Java API. So since the Java API for Arraylist has these methods in here, I thought that they were pretty straightforward, and we need to find some way to implement them in the code. So I have these accessor methods which tell me, first off, if an object is in the list, and second, if an object, where an object is in our array. I also need another accessor called get, which is going to return a type T, and we're going to get whatever's in the index position specified. So notice that my return type T is the same T that we had when we declared our template of class T. It's the same type of T that our data is an array of. And then there's one more accessor that I need. I'm going to need some size accessor that can determine the size of the array list. Keep in mind that when I'm talking about size, I'm talking about the number of elements that we contain, not how big the actual array structure inside is. The array structure is private. The user will never see this. So I've got these accessors, and then I also am going to have some modifiers. So the thing is, we should have ways to put stuff in. So I should have an add method that will add an item of type T to the end of the list. I should have an add method which would return at a particular index item T in that list. I'm going to need a set, which is going to change the spot at index to the item of type T. And I'm going to have remove. So I have a remove, which is going to remove at a particular spot. And I'm going to have remove, which is going to search through and find the first occurrence of an item. And we're going to talk about this, because I'm not too keen about that for reasons that I will explain later. But this is my prototype. In other words, these are all the methods that I think we need to have. We need some private methods, this resize and this need to resize. And we're going to have these public methods that allow us to either get data out of the array list in a specified way, or to manipulate the data in the array list in a specified way. So that's the first thing we have. But there's one thing that I want to do, and I do want to kind of do a throwback to what we were doing in our classes video, that day 3. Our default constructor had a problem, and one of the ways that I can address that problem is by actually doing the code for it in here. So I'm actually going to write the code for my constructor in here. I could write all the code in this file, but that would make this file extremely unwieldy. And so all I'm going to do is write the constructor for this in here. And so there's 3 things that I need to do. I need to get an array set up. I need to initialize the parameters. Remember that we have 2 parameters that we talked about, this array length and this list size. And we're going to just set this up very basically. So I'm going to say that data gets new t of size 5. So this is going to set up an array of size 5, and it's going to have data point to it. Remember that data is a pointer, so this is something that holds a memory address. And we talked about, when we talked about pointers, we talked how pointers and arrays were the same thing. I can either increment the memory address or I can increment the index. Either way will access the data in the array list. And then I need to initialize these parameters. So what I've done here is I've set the array length to 5. And at this point, there is no data in my list. Now, what's nice about keeping track of this list size as a variable is that this is also the spot where I want to add if I want to add something to the end of the list. This is the spot where I want to remove something if I want to remove something from the end of the list. So this gives us a lot of information here. This getting the array set up, you may remember when we did this back in Unit 2, when we talked about how arrays and pointers were the same thing. And of course, these make sense from a coding standpoint. So now that we've got our header file set up, now we need to implement some of this in our arraylist.cpp. Now, the issue that we're going to have here is that for every method that we write, we're going to have to template the method. Because remember that we're not just creating a class of Arraylist, we're creating a class of Arraylist that keeps track of its type. So every time that I write a method, I'm going to have this template class T in front of it. And then I'm going to, when I declare the scope, so like for our resize method, so void ArrayList of type T, remember this is supposed to be a capital T, ArrayList of type T, : resize. So this is our resize method. Keep in mind the purpose of this resize is to resize the array so it can accommodate more data. And we do have a precondition. We need to make sure that whenever we run this, that the size of the array equals the size of the data. In other words, if I had 5 cells in my array, then I also have 5 pieces of data. So I'm going to be operating under that basic assumption in here. And that assumption will actually be addressed with that need to resize method that we wrote earlier. So the post condition, we should have a new array that's twice the size. And in general, this is a good idea when I'm dealing with this fixed data structure inside here. If I'm starting with an array that has 5 elements and 5 isn't enough, my first instinct is to double it. So an array of 10 might be good enough. And if 10 isn't good enough, then 20 might be good enough. The idea is that if I'm doubling at every instance, then eventually I'm going to hit that sweet spot where I don't need to double it any further. Doubling it is going to take more, I'm quickly going to reach the limit of the data rather than the limit of my computer. If I know that I have 40,000 pieces of data, well, let's see, I've got 5, 10, 20, 40, 80, 160, 320, 640, 1280. The powers of 2 go up to 5,000 fairly simple. I'm going to get that jump from 4096 to 8192. So we'll get there within 12 applications of this method. And in general, it's a good idea to just go ahead and double it every time that we would see the need to resize it. So the idea with resizing it is that we'd have to get a new temp array. So we're going to create a new temporary array. So I'm going to say a T array called temp gets a new T array of size array length times 2. Just making sure that I am doubling the array size. And then I want to go through the arrays and copy the data from my data array to my temp array. So for int I gets 0, I is less than array length, I plus plus, and I just want to say that temp sub I gets data sub I. And once I've done that, now I know that my array, my temporary array, now contains all of the elements we have. So I can just say that data gets temp. And now I need to make sure that the array length is fixed. So array length times gets 2. So what we've done here is that we've created a new array here. We've copied the data over using a simple loop. And then we made sure that our data array is now pointing to the temp array spot. So in other words, we've lost the smaller array and we've gotten pointing to the larger array. And then finally, we just keep track of, oh, our array is twice as big as it was before. Now I do want to take care of that idea of when we need to resize. So we're going to template class T again. And we're going to do void array list of template T. And this is our need to resize method. And all I want to do is I want to return the result of comparing our length to list size. So what's going to happen is that this is going to return if the data is equal to the array length. So very straightforward, very simple. So basically what happens is that every time that I want to add something to my list, the first thing I'm going to do is run this method. The second thing I'm going to do is, if this gives me a true value, run this method. So now that my array can accommodate it. And if my array could accommodate it originally, then just running this method is enough, and we never actually jump to the resize. So I want to finish this by dealing with the add situation. So there are two adds that we had here. So the first add we had, class T, we had our void array lists of type T add, and this was adding item T, and this is supposed to add the item to the end of the list. And so what we need to do first is check to see if there's enough space. So if need to resize, then we resize. And now if I've reached this state, either because I needed to resize or because I didn't need to resize, regardless, my array is now big enough to implement what we're looking at. So what I need to do is I need to put the data into that spot. So data at spot list size is going to get item and then list size plus plus. So this takes care of the idea of just adding something at the end of the list. First, make sure there's room at the end of the list, and then we make sure that the last element in our list that's a data element is assigned to the item that we're trying to add to an array, and then make sure that our list size is one more than it was before. So this takes care of this add. So there's one other add that I want to take care of. So template class T, and I've got void array list class T, and this is our add when I want to add something at a particular spot. Now you may remember that we had int index and T item. So this is our overloaded add. And the idea here is that I want to add something at a particular spot, and that means everything else kind of needs to get bumped down. So I'm adding the item to the indicated index. and everything else gets bumped down. So first thing I'm going to do is if we need to resize, then we resize. And at this point, we've resized if we've needed to, otherwise there already is enough space in our array. So what I need to do is I actually need to copy every element from index to the end of the list one spot down. So I'm actually going to do this with a loop starting at list size. And I want to go as long as I is greater than or equal to index. And I want to go backwards. And what I'm going to do here is I'm going to say that data sub list size plus 1 is going to get data sub list size. And so what we're doing here in a nutshell, if I just kind of demonstrate what's going on here, let's say I've got box 0, box 1, box 2, box 3, box 4. And let's say that I've got an 8 and a 2, a 3, and a 2. And I want to insert a 3 in spot 1. So if I want to insert a 3 in spot 1, then my spots are going to be this. I've got my 8, my 3, and my 2, and I'm going to start with my list size value here. List size in this case is 2. This is going to be bumped over here, so this is now a 2. Then this becomes a 3. And this is what the state of my list is as long as I'm at this point here. So now I know that I want to take this and I want to replace that with this data that I've got here. And so now that's when I actually overwrite that with a 3 and we're good to go. So at this point, everything has been moved down where it needs to be. So now I'm ready to put my data in the correct index. So data sub index is going to get item. And then of course, because I've done this shuffling, I need to make sure that list size has been incremented by 1. So I've done this comment in here just kind of to explain what's going on, why I chose this path here. But this is a situation where since I'm trying to bump stuff down, it's easier for me to start at the end and work my way back to the spot that I'm trying to fill. So we've got a couple of add methods in here, and we've got our private helper methods. In our next video, we're going to talk a lot more about the manipulation of data, as well as how to search for things. So once again, this is Mr. Potter. Thank you for watching. Have a great day.